Good day, guys. Darian Giuseppe here, back again with another video for the Key Concept series. What we're going to look at today is implicit differentiation. We're going to look at the first derivative, the second derivative. But before we look at that, we need to look at just some key results with regards to implicit differentiation and understand when we're going to use or when to use implicit differentiation. So let's get straight into the video. Implicit differentiation is the big heading. And let's consider a function, right, or an equation of this form. This is basically an equation of a curve, right? But this equation of this curve here, it has y is here, y squared, and if we were asked to find the derivative of this, we would want to make y the subject of the formula. But in this particular equation, it would be very difficult to do that. And as a result of that, we need to employ implicit differentiation. Because we can't make y the subject of the formula, we will need to make, or we will need to employ implicit differentiation. So implicit differentiation is used whenever we have a function like of this type, where you're seeing x's being multiplied by y's. That is normally be the indication that you use implicit differentiation. It's really when, yeah, you have an equation of a curve that it's very difficult to make y the subject of the formula and then differentiate. So we will look at the derivative of this, the first derivative, and also to the second derivative. But first, let's look at some key results as it relates to implicit differentiation. Once we look at those, then we will start to differentiate. So let's look at these key results. The first key result we need to look at is the derivative of y. The derivative of y is dy dx. So that's pretty straightforward, simple, right? The next key point is the derivative of y to the power of n. That is basically, you use the chain rule here. If we look at it, you bring down the power, that's how you get the n here, and you decrease the power. And then you need to multiply by the derivative of y, which is dy dx. So that is how we get this result here. That is chain rule being employed there. Then next point, or next little result we could look at is whenever you have x being multiplied by y, right, you would get this result here. This result is basically the product rule, right? Because the derivative of x is 1 and 1 by x is y. So that's how you get this first term. And then the derivative of y is dy dx, and dy dx by x is x dy dx. So this employs the product rule. And then lastly, we could look at function of x, or x divided by y. And this is the result you would get here. And this result, we get this result from using the quotient rule. And that's basically it. So these are some key results that we want to look at, right? You want to make sure anytime you have a function of x multiplied by y, you use the product rule. If you have a function of x divided by y, you use your quotient rule. And that would be key there to make sure you understand. Here as well, a chain rule, y being raised to a power n, bring down the power, decrease the power, multiply by dy dx. Some people forget to do that. You want to remember to do that. So now let's get into this here. Let's try to differentiate, right, or find the first derivative of this equation here. So we will approach this term by term. So let's just put down this differentiating with respect to x would give us, let's look at this first term here, x squared y. That looks like product rule needs to be used there. So we would find the derivative of x squared, that is 2x, and multiply by y. So the first term we should get is 2xy. But we're not finished there. We need to remember this is product rule. Find the derivative of y, which is dy dx, and multiply by x squared. So the next term would be x squared dy dx. So this, right, the derivative of x squared y is this entire thing here. That's what we see in there. And then let's look at y squared. The derivative of y squared, you should see quickly that this is chain rule you need to use here. So we need to bring down the power, decrease the power, and then multiply by the derivative of y. So we should get 2y dy dx. And then we will need to find the derivative of this. This is xy. So we find the derivative of x, that would be 1, and you multiply it by y, so you should get y. But remember, this is product rule, so you need to find the derivative of this and then multiply it by this here. So you should get x dy dx. And then the derivative of 2 is 0. And that's it there. That's your first derivative. Right? In some questions, they would ask you to actually make dy dx the subject of the formula. And that's okay. You can go ahead and do that. But if they ask you to find the second derivative, I would advise that you start differentiating this line, right? Do not make dy dx the subject of the formula and then differentiate that a second time. It could make the differentiation very tedious. So you want to attack it from here, right? When you are finding the second derivative. So let's look at the second derivative now. We differentiate again with respect to x, and you will get your second derivative coming into play here, your d2y dx squared. So we go again, we look at this guy here. How do we differentiate that? That is product rule again. So the derivative of 2x would be 2, and 2 multiplied by y. So it's 2y is your first term, but we're not finished with differentiating this yet. Remember product rule. So the derivative of y is dy dx, and dy dx will multiply by your 2x to give you 2x dy dx. And then that's it. So the derivative of this would be these two terms here, right? So now let's look at the derivative of this here. This is again product rule. The derivative of 2x, or rather x squared, is 2x, and then the 2x will multiply by dy dx. So the first term in that product rule would be this, and then the second term would be the derivative of dy dx, which is the 2y dx squared multiplied by x squared. So you should get x squared d2y dx squared. And then we want to look at the derivative of this here. This is another product rule. So you want to make sure you can see it clearly here. You want to make sure that you can differentiate via product rule very good, where implicit differentiation is concerned, right? So we're going back to this here. The derivative of 2y is 2 dy dx, and you're multiplying it by dy dx. So you should get 2 dy dx squared, right? We just multiply it out one time and we will square it one time, right? And we then have to take the derivative of this and multiply it by the 2y. And what that will give us is 2y d2y dx squared. So the derivative of this would be these two terms there. And now let's look at the derivative of y. The derivative of y is dy dx. And lastly, we're looking at the derivative of x dy dx. That would be product rule we employ in here. The derivative of x is 1, so 1 by dy dx. That's the first term you would put down, and then you have to differentiate dy dx, which will give us d2y dx squared and multiplied by x. So we will get x d2y dx squared, and you just don't forget to put your 0 here. The differential of 0 is 0, and that's it. If you are asked to make dy dx or d2y dx squared the subject of the formula, you try to make it the subject of the formula, add any like terms that you have here, and just try to simplify things as best as possible based on what the question is asking you, right? But as well, you want to make sure you understand these key results, just to make sure you understand how it's being employed. And also I understand that whenever you see functions of this form, right, where you're seeing x being multiplied by y, anytime you see that, you should immediately think implicit differentiation. So that's basically it for this video, guys. Implicit differentiation. Like the video, subscribe to the channel for more videos like this, and feel free to share it to someone that it might be helpful to the video, that is, and see you in the next video.